Assalamualaikum and a very good day. Okay, so today we are still in chapter 2 on the random variables. Okay, so we already learned on the discrete random variables. Okay, so in discrete random variable we already learned on the PDF, on the CDF, and how to calculate the probability. Okay, how to calculate the probability, and we already learned on the expected value, variance, and also standard deviation. Okay, so today we are going to look on the continuous random variables on the PDF, and also how to calculate the expected value, variance, and also the standard deviation. Okay, so in the continuous random variables, okay, we have the probability distribution function PDF. So there are three properties of the PDF on the continuous random variable. The first property is that the PDF is greater or equal to 0. Then the second property is that the integration of negative infinity to the infinity of the PDF respect to x is equal to 1. And the last property is that the probability of the A between A and B is equal. Okay, A less than X less than B, or probability of A, X, and B. Okay, it's all same is equal to the integration of AB fx dx. Okay, these are the three properties of the PDF of continuous random variables. Okay, now we look at example 13. So this example 13 is from your notes. Okay, so it is given the continuous random variables, okay, with the PDF. So this is the PDF. So we have the x between the range 0 and 1. Okay, so the question asks you to show that the function is the PDF. Okay, by referring to the properties, okay, the continuous random variables, okay, is PDF when the negative infinity to infinity, the integration of negative infinity to infinity of the function is equal to 1. Okay, now when we look at these questions, your negative infinity, your lower limit is 0 and your upper limit is 1. So that means, okay, the negative infinity to infinity fx dx is equal to 1. That means from these questions, okay, our negative infinity is 0, our lower limit is 0, and our upper limit is 1. Okay, fx, okay, must be equal to 1. Okay, so our fx is equal to 2x. Okay, so now our 2 is a constant, so we can Okay, so we just integrate our x. 0 and 1. Okay, so if we integrate, your x is equal to x squared over 2. Okay, and we have 0 and 1. Okay, so our 2 and 2, then we get x squared. 1 and 0. So 1 square minus 0 square, then we get is equal to 1. So it is shown that the integration of the lower limit and upper limit is equal to 1. So that means it is PDF. Okay, now we look at the next example. Okay, so it is given the continuous random variable with this PDF. Okay, so the question asks to find the value of k. So again, we know that the negative infinity to infinity f(x) dx is equal to 1. So we can get the value of k by using these properties. Okay, now, so 2k is a constant, so we don't need to integrate, we just integrate the variables. Okay, so we want to integrate is 1. So we have 2k. Okay, so we integrate the x, so become x squared divided by 2 minus x cubed divided by 3. Okay, so this one, okay, the upper and lower limit, okay, it depends from the questions. Okay, the function given, your x is between 0 and 1. So that means we integrate from 0 to 1. So your upper limit is 1 as your lower limit is 0. So we have 2k. Okay. So we have 1 over 2 minus with 1 over 3. Okay. Then we have the lower limit is 0. That means we must substitute the x equal to 0 into these equations. Then we get 0 squared divided by 2 is 0, minus 0 cubed divided by 3 is 0. So we have 0. Okay, so we simplify. Okay, then we get 1 over 3k. Okay, so we know that this is equal to 1. Is equal to 1. Okay, from here we know that is equal to 1. So that means 1 over 3k is equal to 1. Then we can get our k is equal to 3. Okay, now we proceed to question number B. Okay, the probability of 0.5 to 1. Okay, so we know that from our properties, okay, the third properties, okay, is already mentioned that the probability of A up to B is equal to the integrations of lower limit up to upper limit of the function. So that means for this one, the lower limit is 0.5, your upper limit is 1, and your fx is your function. So for this one, your function is, okay, we have k is equal to 3. That means our function, okay, is 2k. That means 2 times, okay, is 3, 2 times 3. X minus x squared, or 6x minus x squared. Okay, so this is our function. So it's equal to 6 times with x minus x squared respect to the x. Okay, now 6 is a constant, so we don't need to integrate the 6. We just integrate the variables. Okay, so 0.51 x minus x squared over bx. Okay, so after we integrate, we have x over 2 minus x power of 3 over 3. Okay, 0.5 and 1. Okay, so with mass substitute, okay, when your x equal to 1, okay, minus 2 when your x equal to 0.5. Okay, we start when your x equal to 1. Okay, this one when your x equal to 1 minus when your x equal to 0.5. We substitute into this function. Okay, so it's equal to 0.5 power of 3 divided by 3. Okay, so after we simplify, then we get is equal to 0.5. So this is our probability between 0.5 and 1. Okay, now we look at the question number C. Okay, the question asks to find the probability when your x greater than 0.25. Okay, that means we want to find, okay, when its lower limit is 0.25 and the upper limit, okay, if you see from the question, the maximum value of x is equal to 1. So from 0.25 to 1. Okay, so our function is 6x minus x squared. Okay, again, 6 is a constant. We just integrate the variables x minus x squared dx. Okay, so you get x squared divided by 2 minus x power of 3. Okay, so 0.25 and 1. So your upper limit is 1 and your lower limit is 0.25. So the upper limit must minus the lower limit. So when your x is equal to 1, substitute into this function. Okay, minus with your x is 0.25. Okay, so you will get the answer is equal to 0.8438. So this is your answer.